Now, let's start with the first reaction is basic characters of amine, where we all know that amines have the lone pairs, or the nitrogen has a lone pair, which is the main cause of these amines to be called as Lewis bases or Bronsted bases. Your amines tends to be called as Bronsted bases in water, because what happens is when you talk about RNH2 and water, this hydrogen and OH basically combines with RNH2H plus is taken by RNH2 to form RNH3 plus, and then this plus and OH minus gets attracted towards each other and they form this kind of positive and negative species, which can be written as RNH3 plus OH minus. So basically formation of RNH3 plus on solubility or on dissolving in the water, pulling the hydrogen out of water, and the bond formation with nitrogen is basically the behavior of a Bronsted base. So due to the formation of the hydroxide ions, basically it is taking away the H plus from the water and giving you OH minus. This is the reason why aqueous solution of amines are also basic in nature. In general, the dry amines are basic because of the lone pair, and even in the aqueous solution, they act as basic in nature because they tend to lose OH minus, or they tend to give you OH minus out of the water. This is the reaction with water. Similarly, your amines also react with acids. Again, the acid reactions will be this is base and this is acid, so they tend to form the salt. Again, the lone pair of RNH2 pulls the hydrogen towards itself, get into RNH3 plus form, and X minus plus and X minus forms the respective salts. So salt formation take place whenever the reaction is happening with acids and bases. So no matter whichever acid you're talking about the mineral acid or you're talking about the organic acid, in all the cases, the reaction will remain in the same way. That means the salt formation will take place. Your H plus will be taken by amine, and then the remaining X minus or A minus or B minus, whatever the negative ion is, that will form an ionic bond sort of thing. And the resultant compound will be a salt. So this is your acid-base reactions. Here you have to understand that any kind of acid, no matter it is this weak acid or it is strong acid or whatever kind of acid it is, the reaction will still remain same. So now here I have written few examples. So look at this example. We have aniline with HCl. So again, it is forming NH3 plus Cl minus. I have here the secondary amine with HNO3. So this is also mineral acid. They are also combining with each other and forming salt. So NH is becoming NH2 plus and NO3 minus. So this kind of salt formation will take place. As I said, the reaction is not very specific to only mineral acids. The reaction does take place with the mild acids, or you can say organic acids also. So for organic acids also, the reaction will happen in the exactly similar manner. So this is about the basic nature of your amine. Next is reaction with electrophile. So electrophile means any positively charged species, how your amine will react with it. So amine has a lone pair, and electrophile is a positively charged species, so that will get attracted and will tend to form so basically any electrophile will have an empty orbital, and nitrogen will give its pair of electron, and when this process will happen, basically a coordinate bond formation will take place. So whenever your amines tend to react with electrophiles, the coordinate bond formation or the pi bond formation takes place. Very common reactions are the reactions with transition metal ions. For example, Ag plus, Cu2 plus, all these transition metal tend to form these soluble coordination complexes whenever they react with amines. So look at this salt over here, AgCl. It is in the so AgCl. If you take AgCl, it is Ag plus basically, and we have CH3 and CH3NH2. This is the amine I have. So the pair of electron what I have over here, that pair of electron, and we will have some empty d orbitals and empty orbitals in Ag. So nitrogen will give its electron pair to Ag and will tend to form the complex over here. We have already done the coordination complexes chapter or coordination compound chapter, and there you have seen how the coordination complexes form. So coordination complexes do not depend upon the primary valencies but the secondary valencies. So here it follows the secondary valency thing. Basically, nitrogen looks out for the empty orbital in Ag, put its lone pair there, and the coordinate bond formation takes place. So this kind of complex formation takes place. So basically what we are trying to tell you over here is that all kind of amines are capable of forming different coordination complexes with the transition metal ions like Ag plus and Cu2 plus. So this is your one example. we call it as bismethylamine silver 1 chlorides, and this is soluble in water. So this is one example. You don't have to remember the reaction. The only idea is that amines have the lone pair, and that makes them a good ligands, and they tend to form the coordination complexes with the transition metal ions which have empty orbitals present. So next similar example we have is with the CuCl. So CuCl also have empty orbitals, and NH2 may nitrogen tends to give its pair of electron in the copper's empty orbital, and here it forms the complex with 4 CH3 NH2. So 4 ligands, this will act as a ligand, monodentate ligand, and will attach with Cu, and 4 of such things will form the coordinate bond, and coordination complex will be formed. This complex is tetrakis methylamine copper 2 chloride. As I mentioned, this reaction itself is not required. They won't ask you this to write an example, or they won't ask you to complete this reaction, but this is just to give you an idea that amines are capable of forming coordination complexes by putting their lone pairs in the empty orbitals of the transition metals. The next important reaction is alkylation reaction. Basically here your amines tend to react with the alkyl halide. So basically it is Rx plus R dash NH2. So this reaction we have already performed in the haloalkanes chapter also, which is called as, which we used to call it as monolysis of alkyl halide. So what exactly happens? The hydrogen from your amine and X from your alkyl halide used to go away and used to form HX, and then these two species used to combine. So basically it used to form R-NHR. Secondary amine formation takes place, and this reaction is a repetitive reaction, so this can happen again and again. If you have excess of Rx, this reaction will keep repeating unless all the hydrogens of nitrogen gets occupied, or the valencies, or you can say the maximum covalency of nitrogen gets completed. So the reaction is generally like this: Rx and RNH2 will combine. One X from here, one hydrogen from here will form HX, and you will get R NH R dash. So this is your secondary amine. From primary amine, the preparation of secondary amine takes place. Then you take the secondary amine, do the again reaction with Rx, and again what you get? Hydrogen will go from here, X will go from here, and will form R2. Oh, I'm miswriting N. R2N R dash. This is what it will form. So it is your tertiary amine. Now this tertiary amine has still the possibility of making one more bond with the R group, because it is capable of showing the covalency of 4. So nitrogen can show the covalency of 4. So even if it's a tertiary amine, you can write it as R2N R dash plus Rx. So what will happen? It will do a salt kind of formation where R will attach and X will attach. R will go as an electrophile. So basically it will attack as an electrophile as R plus first of all, and will form R2, and will get attracted towards the lone pair of nitrogen, and will form R3N R dash, and plus charge on nitrogen. Now this nitrogen has got a plus charge, X minus is there in the system. So these two combine and they form the salt thing. So this kind of ammonium salt forms. So everywhere, no matter you talk about the first reaction or you talk about the last reaction, in every case your R group is acting as an electrophile, and your bromine or any X group is acting as a negatively charged species. So here also the alkylation reaction of amine, or you can say reaction with alkyl halides, is also an electrophilic reaction sort of thing, because your Rx will break down as R plus, and this R plus will get attracted towards the nitrogen. Meanwhile, it will kick out hydrogen. Hydrogen will go and attach with X and will come out as HBr. So this reaction is also called as electrophilic reaction. Now, look at the next reaction. We can do the similar reaction with the aromatic amines also. So in aromatic amines, we have taken aniline, and now again you reacted with Rx. So same way as we were doing there, what will happen? Every time the hydrogen will go along with the X, and it will form HX. So here I have taken iodine, so it will remove HI. Here we require a small amount of heat for this reaction to proceed. Even in the previous case, there is small amount of heat is required. So it will form a secondary aniline sort of thing. Then again you supply Rx. Again hydrogen will be kicked out and iodine will be taken away. So minus HI will take place, and it will form a tertiary aniline sort of thing. Then again you reacted with Rx. It will form quaternary aniline sort of thing, where nitrogen has basically nitrogen is 4 degree nitrogen. So this is a salt formation it will take place. So here, in this case, it is a process that primary amine will get converted into secondary, and secondary will get converted into tertiary, and tertiary will convert into quaternary ammonium salt at the end. So that is the way how you can keep on reacting it with haloalkane. And because the repetitive reaction is possible with the excessive alkyl halide, this reaction is also called as exhaustive alkylation. What do you mean by exhaustive alkylation? It will keep on reacting every single time. When it is reacting, the HX comes out, and once the hydrogen is also over, then also the last step of reaction takes place to form the quaternary salt. This reaction and this term is important. This is the meaning of exhaustive alkylation means repeated alkylation of amine. Repeated alkylation of amine is called as exhaustive alkylation, which happens when excessive haloalkane is present. Now, next reaction what we have is acylation reaction. Acylation reaction means reaction of amines with acid chlorides and acid anhydrides. So when you talk about acid chloride is RCOCl. This is your group. Now, how the reaction takes place? Again, this RCOCl, you can also take it as RCO plus and Cl minus. So, this RCO plus acts as an electrophile and gets attracted towards the RNH2's lone pair. So basically, this electrophile gets attracted towards this lone pair, and you can let me just write a probable you can say mechanism for it. So it's like R NH2, R NH, and let me write it as H over here, and the pair of electron, and RCO plus. So this RCO plus will get attracted over here, will form a bond like RNH OCr and hydrogen, and the nitrogen will gain a positive charge. Because it is not happy with the positive charge, it will kick out the hydrogen and it will become RNH. My bad, I have written OCr. It's not OCr, it's COR. Just a second. This is C double bond OR. So here you'll get RCOR, and this H will come out as H plus, and the chlorine, the Cl minus part, will go and attach with it and will form HCl. So basically, electrophile attack will happen first, and then later on HCl formation will take place once nitrogen will gain a positive charge and will kick out the H plus. It will go with the chlorine and will form HCl. So this is how the reaction is happening. So as I said, all the three reactions I have shown you till now are the electrophilic attack reactions. So basically, electrophile is attacking on the amine. Okay. And amines lone pair is acting as the Lewis. Because of the lone pair, this amine is acting as a base, Lewis base, and attracting the electrophilic centers towards itself. So the same thing is happening over here. Chlorine, if you don't want to go by mechanism, you can simply understand it this way, that chlorine is going from here, hydrogen is going from RNH2, HCl is forming, and remaining substances are attaching with each other. So forming R-CONHR. So basically, secondary amide is forming. Now, similarly, look at this. The degree of amine doesn't matter here. We have taken primary amine. I can do the same reaction with secondary amine also. In case of secondary amine, the hydrogen of secondary amine and the chlorine of RCOCl will go together to form HCl, and the kind of amide I'll get is tertiary amide. But this reaction is not possible for the tertiary amine, because eventually the HCl release is required, and it will not be able to release HCl. So tertiary amine won't have the hydrogen. So release of HCl and the electrophile attack will not happen very proper, or you can say the yield will not be very good. And it may end up forming salt kind of thing, but definitely not the compound what we are expecting. So it will not form amide. Here we are getting secondary amide. If I'm taking primary amine, so primary amine is converting into secondary amide, and your secondary amine is converting into tertiary amide. Similar reaction takes place with acid anhydrides also. So what are acid anhydrides? Acid anhydride is RC double bond O, C double bond O, and R. This is your acid anhydride. Now when you will react it with RNH2, let's say, what will happen? Again, this anhydride thing will split into two parts. So it will split from here, let's suppose, and two species will get generated. One will be RCO positive. Again, an electrophile will get generated, and the other part, RCOO, will be like this, RCOO minus. So again, this electrophile will attack on nitrogen, and will form a bond over there. And when it will form the bond, nitrogen will acquire a positive charge. So it will become Rn positive H2 and then attachment with C double bond O and R. Because of the negative positive charge on nitrogen, this nitrogen will eventually kick out H plus to neutralize itself. So it will become the species like this, and H plus will be out. So this H plus will attack here and will form the respective acid. Next is the reaction with aromatic amines. So aromatic amines also behave in exactly same manner. Basically electrophile attack happens, and then on the electrophile attack happen on the nitrogen, and hydrogen and chlorine comes out and form HCl. So basically here also amide formation take place, basically the amide with benzene. So here if you see, this compound is again secondary amide, but this you can also say that secondary aromatic amide kind of compound is there. You have got N-phenyl ethanamide. Similarly, the reaction can happen for the anhydrides also. Anhydrides will also behave in the same manner. The split will happen. One part will be electrophile, will attack on the nitrogen, the hydrogen from here, and the CH3CO part will go together, will form the respective acid. So this reaction takes place in the presence of pyridine, the acyl chloride reaction, whenever you are taking the aromatic amines. Whereas when you're talking about the acetic anhydride, the reaction generally takes place in the presence of acidic medium, that is H plus or CH3COOH. I mean, it can be H plus, simply H plus is written and the reaction will proceed. Now here, there is one important thing. Here in this case, this is a simple alkylation is happening. If you look at the last step here, we have taken again aniline. And aniline is being reacted with benzoyl chloride. So here we are not doing we are not basically taking any R group over here. It is benzene what is getting attached to it, and this kind of reaction, basically exactly same process is happening, that this C6H5CO will be acting as electrophile, will attack over here, H and chlorine will go together and you will get the respective amide. But this kind of step is called as benzoylation. So this is benzoylation of aniline. This process is called as benzoylation of amine, where instead of taking RCOCl, you take PHCOCl. So basically you have taken benzoyl chloride, and benzoyl group is getting added on the benzene. So this is called as benzoylation reaction, and the name of such reaction is also called as Cotton-Baumann reaction. I hope I'm writing the spelling wrong. Otherwise, let's look at the next slide. In that, I would have written the right spelling. So benzoylation of any compound, like you can talk about amines, you can talk about phenols, you talk about alcohols, wherever the active hydrogen is present. Active hydrogen means the acidic hydrogen which can come out as H plus and make the bond with X minus or any negative species which is present with the benzoyl chloride. So basically chlorine is present. So any active hydrogen is present in the alcohols, phenols and amines, and when they are reacting with benzoyl chloride, basically ROH or benzene with OH or aniline. In all the three cases, you have active hydrogen. This is active hydrogen, this is active hydrogen, and here is one active hydrogen which can come out and make the bond with X minus to give you HX. And if you are reacting it with benzoyl chloride, that is benzene with COCl, then what will happen? This benzene and CO thing will get attached to nitrogen here, will attach to oxygen over here, and will attach to the oxygen over here. So basically benzoylation is happening for alcohol, for phenol, or for amine. The same reaction when happening in any of these three cases is called as Cotton-Baumann reaction. But the specific condition which is required is that this reaction takes place in the presence of dilute NaOH solution. So this is the mandatory condition, that this reaction does take place only in the presence of NaOH solution, or you can say alkali solution. It can be NaOH, it can be KOH. But Cotton-Baumann reaction is not very specific to amines. This name is true for phenols also, and this name is true for alcohols also. If they do benzoylation of alcohol, phenols or amines, the reaction will be called as Cotton-Baumann reaction. This is an important reaction, and this is an important question also, because they ask you this in advance. They give you 2-3 reactions which satisfy these conditions. These conditions, as in, they'll give you alcohol reacting with benzoyl chloride, they will give you phenol reacting with benzoyl chloride, they'll give you amine with the benzoyl chloride, and they will give you some other random compound reacting with benzoyl chloride, and they will ask you which of the following reactions is our Cotton-Baumann reaction. So this can be a multiple Correct answer. Alcohol reaction will also be called as this, called through the same name. Phenol reaction will also be called through the same name, and amine reaction will also be called through the same name if these are reacting with benzoyl chloride. So benzoylation of any of these compounds will be under this name itself.
Why do we not use pyridine or aqueous NaOH for the acidic anhydride one?
Acetic anhydride, you're saying this, but these are different conditions where the reaction takes place. So basically, the reaction does require specific kind of catalyst, or you can say the pH medium, right? So here in case of acetic anhydride, we require the acidic pH. Whereas if you see, if you look at the acetyl chloride thing, pyridine is there, which is slightly basic. And if you talk about aqueous anyway, this is also basic in nature, right? So here for RCOCl, we require a basic medium. For anhydride, we require acidic medium.
Okay. Yeah.
Kind of base, how strong, how weak, that may vary, and that is the reason why they are specifically mentioning the aqueous NaOH here. Aqueous NaOH or aqueous KOH, or basically metal hydroxide, will be used as the basic medium here for the reaction to proceed.
Okay.
Benzene based, amine based reactions are generally pH dependent. So these reactions do happen in specific pH only. You just cannot do it randomly. So anhydride reactions basically happen in the acidic pH. Your RCOCl or acid chloride reactions or acid halide reactions takes place in the basic medium. Now, next reaction, what we have is reaction with aldehydes and ketones. These reactions are nothing new. We have done these reactions many a times. We have done this when we were talking about the practical organic chemistry. These reactions we have done in the organic optical isomerism, not optical, I think geometrical isomerism part also. So we have seen these reactions many a times before, that how aldehydes and ketones react with amines. How the reaction takes place: the hydrogen of amine and oxygen of your aldehyde or ketone goes together and gives you the loss of water, and rest of the things get attached. So this, what you get when a primary amine reacts with aldehyde or ketone, is called a Schiff's base. This, the same thing we had done in the practical organic chemistry part also. Here you can have anything, you can have any kind of aldehyde, you can have any type of ketone, and the reaction will proceed. So whatever you will get here will be called as Schiff's base. This is a very important school level question or the board level question. This question I have seen in 1 markers also, 2 markers also, and 3 markers also, that what is Schiff's base. When they ask you in 1 mark, you just have to write the general formula. When they ask you a 2 marker or 3 marker question, you basically have to show the general reaction and 1 example also. So this is very, very important question for the school exam, with respect to school board point of view. Now here you see there is any kind of amine, you can take aromatic or aliphatic. Both will tend to show the same reaction with no matter whichever aldehyde or ketone you have taken. Even your aldehyde ketone can also be aromatic. Your amine can also be aliphatic or aromatic. But if it is primary, but it should be primary for formation of the Schiff's base. The idea is it should be primary amine, any kind of primary amine, aliphatic, aromatic. Aldehyde ketone can also be any kind of aldehyde ketone, aromatic, aliphatic. The reaction will proceed by the loss of water. This reaction will take place in acidic medium because acidic medium accelerates the dehydration of the molecule or dehydration process. It accelerates. So this reaction will take place in the acidic medium. Loss of water will happen all the time, and both the chains will combine with each other. Now, as I said, this reaction is very specific to primary amine, but that doesn't mean the reaction doesn't happen for secondary amine. Secondary amine reaction takes place, but in a little different manner and in the little different conditions. So primary amines will give you Schiff's base. Let's see how the reaction will take place for the secondary amines. So in case of secondary amines, what exactly happens is your aldehydes, they cannot cause the direct loss of water because there are no 2 hydrogens present in the secondary amine. So basically what happens when you take any aldehyde or ketone, we take a condition in which these aldehyde ketones can tautomerize. So we basically provide them certain reagents and catalysts. So we give benzene and PTS. These are 2 catalysts which are there, which basically accelerates the process of tautomerization. So your aldehyde or ketone tautomerize to form an enol. Now look at it very carefully. What is happening here? I have this acetone over here. It will tautomerize and will form acetone's enol form. So basically, at least if we don't know what is what are the different conditions for tautomerization, at least we know what is tautomerization. Tautomerization means the double bond of oxygen breaks down, your oxygen becomes OH, and the double bond shifts to the adjacent carbon. So basically with the beta carbon, you tend to form the pi bond, and one hydrogen goes from there. Let me just tell you again, how does the tautomerization takes place? So basically exchange of hydrogen and double bonds takes place. This double bond will shift over here and the hydrogen will go and shift on the oxygen. This is what happens in the tautomerization reaction. So this will become CH2 double bond C, OH and CH3. So your acetone will tautomerize, or your ketone or aldehyde will tautomerize in the enol form. This is the enol form. And then when it will become enol, then what we have, the nitrogen has only one hydrogen. That was the cause why it was not able to form the water, and the water loss was not happening. But now we have hydrogen over here, and we have OH over here. Look at it. Now my acetone is not acetone anymore. It is in the enol form and it has OH. So OH from your aldehyde or ketone, which has become enol, the OH goes out from here, hydrogen goes out from amine, and then the reaction takes place, and this becomes this kind of structure. So look at it. So we have double bond in the carbon chain now. Earlier, in case of primary amine, what used to happen? If I, let's suppose, have primary amine over here plus CH3NH2. So what will happen? The hydrogen will go from here, oxygen will go from here, and double bond will form between, just a second, double bond will form between nitrogen and carbon. Here the double bond is between carbon and carbon and nitrogen is carrying a single bond. So this kind of species will form. Again, PTS and C6H6 are the reagents which basically accelerates the reaction and let it happen. In the absence of these catalysts, the reaction will not proceed. Though this is not
And the yield of either product would not be that high, right? Because tautomerization keeps happening.
exactly. This reaction is not a very favorable reaction. It's not like the yield will be very good. The yield will be very, very moderate. But the reaction can proceed, and the reaction is reversible, and that is also one reason that you won't get the 100% yield. The yield will be pretty low. And this kind of reaction, they will not ask you in exam, but just in case you get it, the answer is not no reaction. Reaction still takes place. So this kind of compound, the first compound which we have formed with the primary amine are called the Schiff bases. So the product which formed after secondary amine reacting with the aldehyde ketone is called as enamines. The way how you were calling the primary amine and aldehyde ketones reaction product was called as Schiff base. These are called as enamines. Both these enamines and Schiff base can be reduced by hydrogenation. We have two ways. We can reduce it through catalytic hydrogenation, or we can reduce it through NaBH4 also. Either way we'll reduce it, they are going to give us the respective amines. For example, look at this. This is Schiff's base. Schiff's base is the base where there is a double bond between nitrogen and carbon. So this is my Schiff's base. I can reduce it using hydrogen with nickel or NaBH4, and the double bond will break and the hydrogen will get added here. So this will form my secondary amine. Look at this molecule. Here there is a single bond between carbon and nitrogen, and double bond is between carbon and carbon. So this is my enamine, which has formed from the acetone. So this enamine, if I'll take hydrogen or if I take NaBH4, it will reduce this also. So basically this pi bond will break, one hydrogen will get added over here, one hydrogen will get added over here, and I'll get the respective amine. Now what kind of amine it will be, that will depend upon the degree of amine you have taken in the reaction, initially in the reaction itself. So here I can see my amine is tertiary amine. So it will remain as a tertiary amine over here. So basically you are not adding hydrogen to nitrogen in the second case. The hydrogen is just getting added in the alkene part of your carbon chain. In enamine, the hydrogens will get added in the alkene, whereas in case of Schiff base, the hydrogens will get added on the double bond, which is between nitrogen and carbon. Okay, so now next is very important reaction. I think we have done this reaction while we were doing the tests or practical organic chemistry also. This is reaction with chloroform, and we call it as carbylamine reaction or isocyanide test. Very, very important reaction with respect to the competitive exams. They ask you this reaction very, very directly asked in mains. Mains it has been asked thrice or 4 times. Sometimes they have asked you which of the following is the carbylamine reaction. You just have to find out. Or many a times they have given you this reaction and you have to complete the reaction. Basically, you have to just mark the right product. The reaction takes place only for primary amines, okay, not secondary, not tertiary. So this reaction is shown by primary amines. So it is a test for primary amine. You do the reaction with chloroform and alcoholic KOH. In the presence of alcoholic KOH, CHCl3 reacts with the primary amine and it gives you isocyanide. The formation of isocyanide takes place, which is very foul smelling compound. As soon as the isocyanide forms, very bad smell comes out, and that is the indication that your amine was a primary amine, because there is no color change. So you cannot observe it through the color, or no special gas releases, as in there is no special colored gas comes out which can help you in identifying, but very bad smell comes as soon as the isocyanide forms. And this is the test. This is very, very, very important named reaction. Here you can also see when you talk about the amine has whatever the number of carbons were there, the total number of carbons will be 1 extra when the product will be formed. Basically, if you have CH3NH2 and you are reacting it with CHCl3 and KOH, in your product you will get CH3NC. Total molecule will have, or total product will have 1 extra carbon, which is due to the isonitrile group or isocyanide group. Very, very important test. This is shown by all kind of primary amines. You can call it as aliphatic amine will also show this reaction, and aniline will also show this reaction. So it's not specific to the aliphatic primary amine. Aliphatic primary amine and aromatic primary amine both will tend to show this reaction and will form the respective isocyanates. This test is clearly not given by secondary and tertiary amine. So the test is about the foul smelling compound. You will not see any color change or any other observation. This is very, very simple, but very, very important reaction. For board point of view also, they directly ask you this reaction, named reaction from the nitrogen containing compound chapter. Very, very important reaction it is. Next are few miscellaneous reactions. Whatever the reactions we have done till now, all of those reactions were the electrophile attack on the nitrogen. Everywhere there was an electrophilic end which was attacking on the lone pair of the nitrogen, and the electrophile, and so basically Lewis acid Lewis base reaction is happening, and then the next step of reactions were proceeding. So in every single reaction what we have done just now, there were some electrophile ends which were attacking on the nitrogen, though I have not explained you the mechanism of all, but that was the general category. Now what we are going to do is the miscellaneous reactions which are not following any specific kind of sequence. Sequence as in, there is no particular sequence that the electrophile is attacking first, then the nucleophile. So these are varied reactions and have various different performances. But again, very, very important tests are there in these miscellaneous reactions. First reaction what we are gonna do is the reaction with nitrous acid. This reaction also we have covered when we were doing the test or practical organic chemistry, POC. Nitrous acid is HNO2, which can also be written as HCl plus NaNO2. This reaction is, this is amine reacting with HCl and NaNO2. If we do the reaction for, let's say, aniline, NH2 with HCl and NaNO2, I'm not very sure whether you remember this or not, but this used to form diazonium salt, and the reaction is called as diazonium reaction or diazonium salt reaction. This reaction is the first very important named reaction what we had done in haloalkane chapter. Here HNO2 is produced in situ, and this is always produced with by the combination of NaNO2 and HCl. So many a times when they want you to do the reaction with nitrous acid, they may give you directly HNO2, or they may give you this combination. You have to understand this NaNO2 is nothing else but HNO2, because HNO2 itself is a very unstable acid. So we have to produce it in situ using NaNO2 and HCl. Now this reaction with HNO2 can happen for primary amines also, can happen for secondary amines also, and can happen for tertiary amines also, aliphatic amines also, and aromatic amines also. But the observation will be different in each case. Observation will be different and reaction will be different in each case. So let's first understand the reaction with the primary amines. Primary amines may, as I mentioned, that HNO2 is unstable, so it is always prepared in situ. So NaNO2 and HCl is being prepared in situ over here. is getting prepared in situ over here. Now, when the reaction is taking, your aniline will get converted into diazonium salt, which we have already discussed before. In many chapters, we have discussed this in alcohol chapter also, and we had discussed this in haloalkane chapter also, and the loss of water takes place. Now, this reaction, as I said, is called as diazonium reaction. This reaction is quite possible at low temperatures. Now, as soon as the temperature changes or temperature increases, the temperature is somewhere around 298 Kelvin, 275 to 298 Kelvin. That is the temperature range what we keep over here. But as soon as you increase the temperature, the reaction between diazonium and the water which has got released, that also starts happening together. So basically at higher temperature, your diazonium N2Cl will react with the water which has come out as a product at higher temperatures, and eventually this diazonium will get converted into alcohol group. So OH, so your N2Cl gets converted into OH, N2 comes out as nitrogen gas, and from H2O, OH goes and takes the position, chlorine comes out, and this H and this chlorine go together to form HCl. So product forms is phenol, nitrogen gas, and HCl. But this reaction takes place at higher temperature, whereas the formation of diazonium itself takes place at a very low temperature. Low temperature is just above the room temperature. So if you increase the temperature, these two will start reacting with each other and eventually will get converted into phenol. Let's see it here. I have written this reaction in the next slide. So here I have shown you, this is my diazonium salt. Again, if the temperature is around, it's 298, sorry. If it is greater than 298 Kelvin, it will give you phenol, nitrogen gas, and HCl. So this is the reaction what we have done in alcohols. This was the preparation of phenol. So this is when I have taken aniline. So basically aromatic primary amine. If I take aliphatic primary amine, the behavior is a little different for the reaction. Aliphatic primary amine will directly give you alcohol. The reaction takes place at 273 to 278 Kelvin. What exactly happens is here also diazonium kind of salt forms. It's not like it doesn't form, but it is highly unstable, highly unstable, and immediately gets converted into alcohol. So you get R2NCl, but this is highly unstable, sorry, RN2Cl. This is highly unstable and quickly goes and converts itself into alcohol part. So you don't get to extract out this. So it's not like that from the reaction mixture you can extract out this kind of diazonium. You cannot. It will just, as soon as it will form, it will immediately convert it to alcohol form, nitrogen gas, and water will be released. So your aliphatic primary amines give you alcohol. Your aromatic primary amine will give you diazonium salt, which on higher heating give you alcohol. But at lower temperature, it can remain and it can sustain as diazonium salt. This is a very important test for aliphatic primary amines. In case of aliphatic primary amines, you will see the release of nitrogen gas at room temperature itself. At room temperature itself, when you will do the reaction with HNO2, you will see the release or evolution of nitrogen gas. Whereas if it is aniline, that is aliphatic primary amine, you will not see the release of nitrogen gas over there. There will be no change or no gas or no color changes happening. But in case of primary amine, the release of nitrogen gas will be happening. This is a very important test for aliphatic primary amines. And what is the observation here? Observation here is the release of nitrogen gas or evolution of the nitrogen gas. Now let's move to the next. So next is reaction with the secondary amine. The reaction with secondary amine is also pretty different from what it happens for the primary amines or primary aliphatic or aromatic amine. Now here again, look at it. So here what we have is, here we have hydrogen in the, it's like R2NH kind of setup. And if you look at your HNO2, this is the structure of HNO2. So you can take OH out of it and hydrogen out of it, and the loss of water can take place. So this is how the reaction takes place. The hydrogen of secondary amine goes out, OH from HNO2 goes out, and water release happens, and the remaining substances combine. So this kind of nitroso product forms. This is a nitrosoamine. This we call it as nitrosoamine. So nitrosoamine forms. Both aliphatic and aromatic secondary amines react with HNO2 and give you N-nitrosoamine, which is insoluble in the mineral acid. That means you take HCl, you take H2SO4 or any acid, it will be insoluble, and it will, if you'll try to dissolve it over there, it will react and it will form It will not dissolve. It will do some sort of reaction, and a neutral yellow oily compound will be formed. Or you can say, let's not say it this way. So basically, whenever you're talking about the formation of HNO2, I told you this thing that HNO2 is not something which we are supplying from outside. We are basically giving NaNO2 and HCl. So there is a possibility that in the reaction mixture there is some more amount of HCl is present, and not everything has got converted into HNO2. So even if slight amount of HCl is present over there, your product which has formed N-nitrosamine, that will not dissolve into this HCl. Instead, it will separate out and will form a film over the solution or the reaction mixture, and that film will be yellow oily liquid, which is clearly visible and can be easily separated out from the reaction mixture. So the product form here. So here the observation is, you can also do this. You can use this reaction for the testing again. You take a primary amine and you take a secondary amine, and you want to figure out which one is primary, which one is secondary. If primary is doing the reaction, it will release nitrogen gas. If secondary is doing the reaction with HNO2, it will give you yellow liquid. And yellow liquid cannot tell you whether this is an aliphatic amine or aromatic amine. That can just tell you the degree of amine. So this degree of amine is secondary over here, no matter you talk about aliphatic thing or you talk about the aromatic thing. Unlike your primary amine. In case of primary amine, your aniline doesn't give you nitrogen gas, whereas your aliphatic amine, normal straight chain anilines, gives you nitrogen gas as a product. So this reaction can be used to differentiate between aniline and aliphatic primary amine. Other thing, it can be used to distinguish between primary aliphatic amine, or any primary amine, not aliphatic, primary amine and secondary amine. So here you will go by the observation, what we'll see in the secondary amine will always give you a yellow colored liquid. There is another thing also, what we do to ensure that this compound is a secondary amine only, what we have taken as a reagent initially. We take these nitrosamines, we warm them with the phenol thing. We warm them with the phenol, and we add concentrated H2SO4. Both the things, when we add, we will see green solution, green color liquid forming. That green color liquid, so this test is called as Lieberman nitroso test, which is again a very important test. And what is forming when you treat it with phenol and concentrated H2SO4, it will give you green color thing. Then again you treat it with NaOH, it will become deep blue, and then if you dilute it will become red. So basically multiple color changes are happening, and this is called as Lieberman nitroso reaction. This is the test for secondary amine. Even if you don't do such a long process, just preparation of yellow oily liquid itself gives you the identification test of secondary amine.
So you react the N-nitroso amine with this, with NaOH to do this test?
Yes.
Okay, fine.
Next is the reaction with tertiary amine. Again, tertiary amine will have its own different type of reaction happening with HNO2. What happens when we react aliphatic tertiary amines with this? They will tend to form nitrite salts, water soluble nitrite salts, whereas aromatic tertiary amines will go through the electrophilic substitution on benzene, and nitrosonium ion attaches on the para position. I'll show you both the reactions. In the first case, if you see, this is my tertiary amine, and when I'm reacting it with HNO2, basically what is happening, the H plus, it will break down as H plus and NO2 minus. Now H plus is your electrophile, will go and attaches on the lone pair of the nitrogen, and nitrogen will get a positive charge, and then it'll be like this. See, this is a simple acid base reaction sort of thing. You will get CH3, CH2 whole thrice, NH and plus. Now you have NH plus and you have NO2 minus in the system, as in the solution. So that will also come and will form a temporary ionic bond, or you can say these ions will come closer and the salt will be formed. So this salt is called as nitrate salt, nitrite salt, and this will be soluble in nature. Okay, so basically this will be water soluble salt. Now the similar reaction will not happen in case of aromatic amine, whereas aromatic amines will perform the reaction very differently. Here you will have NO group over here. You have this tertiary amine thing, and then this is your benzene. So it will, this thing will not act as, the hydrogen will not go to nitrogen, this nitrogen will not act as a Lewis base over here. Instead what is going to happen, this whole HNO2 will break as OH minus and NO plus over here. This NO plus will act as an electrophile and will attack on the para position. Basically this amine group is ortho and para directing. This NO could have gone to the ortho position, but it will face a lot of repulsion due to the steric hindrance. So it will preferably go to the para position and will attach like this. And hydrogen, which will come out from this position, will make the bond with OH to form water. So here the reaction is different. In both the cases, electrophile attack is happening. Basically, H plus is coming out, attacking on the nitrogen's lone pair, and here NO plus is coming out and attacking on the para position of the benzene. Attack is different, and the product forming is also different. So product what will form here is again a nitroso compound, which will be green in color. This is all these three reactions of primary, secondary, and tertiary amine with HNO2 are very, very important for competitive exams. They're not school exam, but are very, very important for competition. So note them down properly when I'll give you the video link, and make sure you remember them. They ask you a lot of questions from this part. Next is reaction with Grignard reagent. Reaction with Grignard reagent, we have already discussed in the Grignard reagent chapter itself, that you have the acidic hydrogen in amines. So basically only primary and secondary amines tend to react with Grignard reagent because they have these acidic hydrogens over here. And these hydrogens will go along with the delta negatively charged R dash of Grignard reagent will form alkane, and the other side products will be formed. This reaction, I don't think I need to elaborate it any further. We have done Grignard reagent in a lot more detail when we did this chapter. So you can just refer to that. Only thing you have to understand is your amine have the acidic hydrogen, which will go along with the alkyl group of your Grignard reagent and will form the respective alkane. Next reaction, what we are doing is reaction with carbon disulfide. So reaction with carbon disulfide can be done with aliphatic amines also, and can be done with the aromatic amine also. Yeah, so this is an important test. So basically this reaction with carbon disulfide takes place with aliphatic amines also, and it takes place with aromatic amines also. But the conditions what are required are different in both the cases. So when we are doing the reaction with aliphatic amines, we will take carbon disulfide, we will warm it, and there is a dithio salt type of thing will form. Basically, when you talk about carboxylic acid, this is your carboxylic acid. But when you do the same, when you do the reaction with amine, it tends to form, basically this will be your electrophilic center. It will form C, S double bond C plus and S minus. So this will become your electrophilic center, which will go get attached to the nitrogen. So, and then it will form this thing with the hydrogen. So I'll just show you the reaction. So what will happen is it will form RNH, and I'll write it as carbon S minus and double bond S, and nitrogen will carry a positive charge. This is what will form. Now because nitrogen has got a positive charge, it will break its bond with hydrogen, eventually forming RNH, C, S minus, double bond S, and H plus is out. This H plus will go to these sulfur here and will form SH. So this is what exactly I have written over here. RNH, single bond C, double bond S, and SH. So this, the way how we have carboxylic acid group, similar kind of group has been formed over here, but instead of oxygen, we have two sulfurs over here, and this will be called as carbamic acid. Carbamic acid. Carbamic acid. This is the acid which is formed by sulfur, not oxygen. Now, once we have got this acid, we will treat it with HgCl2, and we will get Rn double bond C double bond S, this kind of compound. Okay, and this is the compound which has an appearance, which has a smell like mustard oil, and that is why we call this test as a Hoffman mustard oil test, because the compound which is forming has a mustard oil smell. Now, this reaction is pretty much possible with the aliphatic amines, and they do it in this way. We first treat it with CS2 and then we treat it with HgCl2 to get mustard oil smell. If I have to do the same reaction with, let's say, aromatic amine, then what will happen? In case of aromatic amine, I have taken the C6NH2 and I'm treating it with CS2, but we cannot treat only with CS2. We have to take the KOH along. So only CS2 reaction will not happen. It will happen in the presence of KOH. And again, this KOH will not participate in the reaction. This KOH will just act as a reagent, or you can say catalyst over there, or even participation means it will not participate in the formation of actual product. So here, just look at the reaction. How is it happening? So you have hydrogen over here. Here you have a hydrogen. So 2 hydrogens and 1 sulfur will come out. So H2S loss will happen. So basically 2 hydrogen and 1 sulfur will be out. Carbon will have 2 valencies and a sulfur will be present over here. So I'll just write over here. So it will be C double bond S and S. From these 2 bonds, I have taken 2 moles of aromatic amine or 2 moles of aniline, you can say. C6H5NH will get attached at one position and C6H5NH will attach on the another position. So this kind of molecule will be formed, which will be called as N, N dash diphenyl thiourea. And then what we have got is H2S. This H2S will react with KOH, which is present over here, and will form K2S and H2O. This will be the side product. Though we are not even bothered about what is forming over here, this is important. Once we have got this, then this will be treated with HCl. So look at the flow of the reaction. In previous case, there was nothing like this was happening. Even the reaction was happening in a completely different manner. There it was an electrophile attack sort of thing. Here there is a loss of H2S is happening, and then reaction with HCl is happening. So here, when the reaction with HCl will happen, then this whole molecule will get converted into, basically it will split into the parts and it will form C6H5N double bond C double bond S. So basically this whole thing will be out. This whole thing will be out. This hydrogen will also be out, and this will come out as C6H5NH2. You can also take it as one of the part will break, nitrogen will also lose its hydrogen, the C6H5NH will be out, it will come out as amine, and then your C6H5 nitrogen will form double bond with the carbon and then sulfur. Because one valency of carbon has got free over here, nitrogen's one valency has got free over here, so they'll form double bond, and this kind of isothiocyanate will form. Eventually, in both the molecules, no matter you have taken primary amine or you have taken aromatic amine, both are forming isothiocyanate, but the process of reaction or how the reaction is proceeding is completely different. And in fact, the reagents required for the reaction are completely different except CS2. Both will give you the same thing. Both will give you thiocyanate. Both will show the positive effect for Hoffman mustard oil reaction. Both will have the mustard oil smell, but the reaction which will take place in a different manner. Different set of reagents will be taken. We will be taking. That is why we say that the aromatic amines and the other aliphatic primary amines react in completely different setup. This is also a test for primary amine with any other amine secondary or tertiary, because primary aliphatic or aromatic amine will tend to give you mustard oil smell product, that is your isothiocyanate, but your secondary and tertiary will not perform this reaction. Diphenyl thiourea. This group is urea group, NHCNH. I mean, basically urea group is NH, C double bond ONH, and this is called as thiourea because there is S instead of oxygen.